What happens to a body 50 years after burial? It's not just a question, but a dive into the fascinating, sometimes shocking world of post-mortem changes. So the moment of truth has arrived. Life has left the body, but that doesn't mean instant disappearance. On the contrary, death triggers a complex and incredibly ordered process, decomposition. And it starts not in days or hours, but within minutes. Imagine, the heart stops, breathing ceases. Cells, deprived of oxygen and nutrients, begin to starve. Inside each one are tiny sacs called lysosomes, containing powerful digestive enzymes. When alive, they're strictly controlled, but after death, their locks weaken. The enzymes break free and start digesting their own cells. This is called autolysis, or self-digestion. While these microscopic dramas unfold inside, changes are also visible on the surface. The body gradually cools to the surrounding temperature. Algor mortis. Blood, no longer circulating, settles in the lowest parts of the body due to gravity, creating lividity, or livor mortis. These purplish-blue marks are important indicators for forensic experts. Several hours after death, rigor mortis sets in. Muscles lacking ATP, an energy molecule, can't relax and gradually stiffen. This starts with the small muscles of the face and neck, then spreads to the limbs. Rigor mortis usually peaks after 12 to 24 hours and lasts for 2 to 3 days, then gradually disappears, giving way to further decay. All these stages are just a prelude to a grand transformation. What if I told you the most active workers at this stage are completely invisible to the naked eye? Ready to learn how billions of microorganisms and insects kickstart the true mechanism of decay? If autolysis is the internal process of cellular self-destruction, the next stage involves an entire army of external helpers. Billions of invisible microorganisms and communities of insects come into play. It's a true spectacle of nature, where each participant returns organic matter to the cycle of life. First on the scene are bacteria. Many already live in the intestines, but after death, when immunity weakens, these bacteria, as well as those that enter from the outside, begin to multiply rapidly. In the absence of oxygen, anaerobic conditions, they trigger putrefaction. This process releases gases, methane, hydrogen sulfide, ammonia. These gases cause the body to bloat and produce that specific, unmistakable odor of decomposition. Cadaverine and putrescine are the main culprits behind this aroma, products of protein breakdown. This signal attracts other participants. Next come the insects. The main players are flies, flesh flies and carrion flies. Attracted by the smell of flesh, they lay eggs in natural openings and wounds. Larvae, or maggots, quickly hatch from the eggs. These small, voracious creatures are true processing machines. They feed on soft tissues, rapidly increasing biomass and accelerating decay tenfold. As the maggots eat most of the flesh, other insects appear. Dermestid beetles, mites, ants. Each species specializes in certain stages, forming a complex food chain. These invisible and inconspicuous workers are a key link, transforming complex organic matter into simple elements that become part of the soil and new life. This will change your perception of how long a human body lasts. When soft tissues give way to bone, a story begins that can last for centuries. After the army of microorganisms and insects completes its main task of processing soft tissues, the next very important stage begins: skeletonization. This is the moment when the human body essentially turns into its skeletal frame, opening a new chapter in the history of post-mortem changes. Imagine seeing not the body in the usual sense, but its internal framework. This process can take from a few weeks to several years, depending on environmental conditions. In hot and humid climates, skeletonization occurs faster, thanks to the activity of decomposing organisms. In dry and cold conditions, the process slows down, and the body may even mummify. But what happens to the bones themselves? Bones aren't just hard sticks. They consist of organic matter, mainly collagen, which gives them flexibility, and inorganic minerals, mainly calcium hydroxyapatite, which provides hardness. After the soft tissues disappear, the organic part of the bones also gradually decomposes under the influence of bacteria and fungi. However, the mineral part is much more resistant. That's why skeletons can be preserved for decades, centuries, or even millennia. The conditions of burial play a key role. In acidic soil, for example, bones break down faster because the acid dissolves the minerals. In alkaline or neutral soil, especially if it's dry and dense, bones can be preserved much longer, sometimes even turning into a kind of fossil, that is, mineralizing, replacing organic matter with surrounding minerals. In addition to the chemical composition of the soil, preservation is affected by humidity, temperature, burial depth, and, of course, the absence of mechanical damage from animals or humans. Thus, a skeleton is not just remains, it's an amazing archive that can store information about a person's life and the conditions of their final resting place for an incredibly long time. Picture this: 50 years after burial, during accidental earthworks, an excavator hits an old coffin. What will it find inside? It's not just bones, it's a whole story told by nature. So we've traced the path of the body to skeletonization. But what will remain after half a century underground? It depends on many factors, forming a unique picture of post-mortem existence. After 50 years, only the skeleton will remain of the human body. Soft tissues, with rare exceptions, will have long disappeared, processed by microorganisms. The condition of the bones varies greatly depending on the type of soil. In acidic environments, like peat bogs, bones can be destroyed or even dissolved. In neutral or alkaline soils rich in calcium, they're preserved much better, becoming dense. The fate of the coffin is also sealed. A wooden coffin, unless it was made of particularly strong wood or without protection, is likely to completely decompose. Moisture, bacteria, and fungi will leave no trace of it, except for heavily corroded metal elements, handles, hinges, nails. However, if the body is placed in a sealed coffin or concrete vault, the picture is different. In conditions of limited oxygen and moisture, Adipocere, grave wax, may form. This soap-like substance from fatty tissues can surprisingly preserve the contours of the body for decades. The influence of the environment is colossal. Dry, sandy soils slow down decomposition, promoting mummification. Moist clay soils can accelerate decay, but create conditions for adipocere. Temperature and burial depth are also critical. A deeper and colder place provides stability and slows down all processes. Thus, after 50 years, we're likely to find a skeleton, possibly with fragments of clothing or hair, and only remnants of the coffin. Each burial is a unique natural experiment, where time and the elements write their story. Amazingly, in 50 years, up to 99% of our body completely returns to the ecosystem, becoming part of the soil, plants, and new life. It's not the end, but a fundamental link in the eternal cycle of nature. We've gone all the way from the first minutes after death to half a century underground, observing an amazing transformation. And now, we've come to the most important thing, understanding that decomposition is not just disappearance, but an essential part of the eternal cycle of life on our planet. Every atom, every molecule that makes up our body was once part of the earth. After death, they return there. The bacteria, fungi, and insects we called invisible workers perform a critical role. They don't just destroy organic matter. They break down complex substances into their simplest chemical elements: carbon, nitrogen, phosphorus, potassium. These elements become nutrients, enriching the soil. Soil, saturated with these elements, becomes a fertile foundation for new life. Plants absorb these minerals through their roots. Then these plants become food for animals, which in turn can be eaten by others. Thus, what was once part of a human is once again included in the ecosystem, feeding forests, fields, and all the living world around us. It's a powerful reminder of our place in nature. Death is not the final end, but a necessary stage that ensures the continuity of life. Without decomposition, the planet would be littered with dead organic matter, and new generations wouldn't be able to grow. We're part of this grand, endless dance between life and death. Realizing this gives profound meaning to our existence, emphasizing our inseparable connection to the entire biosphere. In every new sprout, in every drop of rain, in every breath, there's an echo of what we once were. We've just taken a fascinating, albeit sometimes macabre, journey into the world of post-mortem transformations. If this topic has made you think about the eternal cycle of life and death, about what remains of us in this world, then join the Mysteries of the Spirit channel. Here we explore the deepest and most mysterious questions of existence. Don't forget to like this video so that more people can learn about these amazing processes.